Toyota couldn't do it, Tesla didn't try, and yet a factory in China is doing it right now, stamping out an engine that runs at 43 phNTRM thermal efficiency. Every 30 seconds, around the clock. That number rewrites what's possible. The best mass-market engines on the planet sit at 35 phNTRM. BYD blew past that and built the factory, the battery, the motor, and the semiconductor chip to go with it. No supplier, no partner, nobody else in the room. This video goes inside the machine. Ask most people where BYD makes its cars and they'll say China. Ask where the engines inside those cars come from, and almost nobody knows the answer. That answer starts with FinDreams Powertrain, BYD's internal manufacturing division built specifically to produce engines, electric motors, transmissions, and complete hybrid system assemblies. No outsourcing. No dependency on third-party suppliers for the components that matter most. Everything designed, tested, and produced under BYD's direct control. As BYD's headquarters city, this is the center of R&D activity, where prototype lines test new engineering concepts before committing to full-scale production. The decisions made in Shenzhen's labs eventually define what rolls off assembly lines hundreds of miles away. Changzhou is where those decisions scale into industrial reality. This plant operates like a self-contained manufacturing city. A finished vehicle exits the line every 30 to 60 seconds, not as a showroom claim, but as a documented production rate. Hybrid powertrain components are cast, machined, assembled, and integrated simultaneously, with robotic systems running continuously across all 3 shifts. Xi'an handles roughly 900,000 vehicles per year, focused primarily on hybrid SUVs and sedans, the BYD Song, the BYD Tang, and serves as one of the main facilities where complete DMI powertrain units are assembled and validated before vehicle installation. Changsha, in Hunan Province, runs parallel hybrid production lines that combine skilled technicians with some of the highest automation rates in the entire BYD manufacturing network. Hefei is the newest facility, purpose-built modern infrastructure for next-generation, hybrid and EV production, strategically expanding BYD's reach into central China. Across all locations, BYD operates 8 to 9 major production bases, with a combined annual output of 5 to 6 million vehicles. And that number is still climbing. It manufactures the engine block, the motor windings, the battery cells, the gearbox, the power electronics, and through its subsidiary BYD Semiconductor, even the chips that control the entire system. This level of vertical integration has no direct parallel in the global auto industry. Volkswagen relies on hundreds of external suppliers. Toyota sources batteries from separate partners. BYD has absorbed the majority of its supply chain in-house, which translates into lower production costs, tighter quality control, and the ability to scale faster than any competitor waiting on outside factories. When BYD needs to increase volume, it adjusts its own lines. That's not just an operational advantage. It's a structural moat that cannot be replicated quickly. The scale of what BYD is currently producing is genuinely difficult to absorb all at once. BYD launched the world's first mass-produced plug-in hybrid, the F3DM, back in 2008, years before most Western automakers were treating the technology as anything more than a concept. By 2026, cumulative FIEV production across the company surpassed 7.7 million vehicles. No competitor is within reach of that figure. In 2025 alone, BYD produced and sold over 4.6 million new energy vehicles. And here's the number that blindsided the industry. In several months throughout that year, plug-in hybrid sales actually outpaced pure EV sales within BYD's own lineup. Not because EVs were too expensive, because the DMI hybrid offered something a full electric vehicle still can't match. Genuine long-distance freedom, combined with an electric driving experience for every commute, every errand, every city trip. A single DMI powertrain production line, as far back as 2021, already had rated capacity for 500,000 units annually. Today, multiple lines run in parallel across several facilities. Combined annual DMI output now runs into the millions of units. At Changzhou, the numbers become almost hard to visualize. One vehicle every 30 to 60 seconds, 24 hours a day. Automation levels at BYD's leading facilities are reported at 97 phNTRM. Meaning 97 out of every 100 assembly tasks are executed by machines. Human workers monitor the systems and manage exceptions. The robots do the building. Since 2022, BYD has produced 0 pure petrol vehicles. Every car leaving a BYD factory is either fully electric or plug-in hybrid. Every robot, every production line, every manufacturing facility, entirely committed to new energy vehicles. The outcome: production records broken year after year, in sequence. Understanding the production process reveals how BYD maintains quality at this volume. Because quality and volume are usually in tension. And BYD has engineered its way around that. It starts with raw materials, steel, aluminum, and specialized alloys arriving at the facility, and immediately splitting into 2 parallel tracks, casting and forging. In casting, molten metal fills precision molds to form the basic engine block geometry. In forging, metal billets are compressed under extreme pressure, increasing molecular density and structural strength. Both processes are fully automated from start to finish. The engine at the center of this process is BYD's 1.5-liter Xiaoyun, an internal combustion unit engineered from scratch to live inside a hybrid system, not to operate independently on a conventional drivetrain. Its thermal efficiency reaches 43 phn/TRM. A typical mass-market petrol engine sits between 25 phn/TRM and 35 phn/TRM. The Xiaoyun converts meaningfully more fuel energy into mechanical work and loses significantly less as wasted heat, a gap that translates directly into fuel consumption figures at the consumer level. From casting and forging, the rough engine block enters CNC machining. Computer-controlled cutting tools operate to tolerances, measured in microns. Cylinder bores are cut to exact dimensions. Mating surfaces are ground flat. Oil galleries and cooling passages are drilled, inspected, and pressure tested. Pistons, crankshafts, and connecting rods are installed by hydraulic torque systems that apply identical, repeatable force every single cycle. Because in a hybrid engine that must start and stop on demand thousands of times per year, mechanical precision is non-negotiable. Next comes the EHS unit, the electric hybrid system, which is where BYD's engineering makes its clearest departure from conventional hybrid architecture. The primary drive motor and the generator motor are packaged together in a single compact housing. Motor windings are assembled on a dedicated automated line. Magnets are positioned with precision tooling. Cooling circuits are assembled and tested before system integration. The completed EHS unit is then joined to the engine block, along with an inverter, reducer, and central controller, forming a single integrated powertrain assembly compact enough to fit cleanly into any standard vehicle platform. The blade battery pack, assembled through a separate process, connects to this powertrain, with a battery management system monitoring cell temperature, state of charge, and energy distribution across the pack in real time. Before leaving the production floor, every unit runs a full bench test sequence: power output measurement, fuel consumption verification, thermal behavior under load, vibration analysis, acoustic profiling, and complete electrical validation. Any unit that falls outside specification is pulled for rework. Only confirmed units proceed to vehicle integration. Once installed in the vehicle, the completed car runs a dynamometer test, simulating real driving loads at multiple speed points, without moving from the test bay, followed by water ingress testing, software calibration, and a multi-point final inspection. Nothing ships without clearing every stage. DMI is not a refined version of an existing hybrid concept. It represents a different underlying philosophy, and the distinction has real consequences. Toyota's hybrid synergy drive is engine primary. The petrol engine handles the majority of propulsion work, with an electric motor stepping in during acceleration or low-speed driving. The system is proven reliable and has powered tens of millions of vehicles, but it was conceived in a different era, optimized around a different set of trade-offs. BYD's DMI is electric, primary. The electric motor drives the wheels as the default mode. The battery supplies the energy. During everyday city driving on a reasonable charge, the petrol engine stays off entirely. The result is a silent, smooth, responsive experience that is, for practical purposes, indistinguishable from driving a full EV. When the battery drops below a calibrated threshold, the petrol engine starts, but it doesn't connect mechanically to the wheels. It drives a generator, which produces electricity, either fed directly to the motor or used to recharge the battery. Critically, the engine runs at a fixed RPM, held at its most thermally efficient operating point, regardless of vehicle speed or road conditions. It doesn't hunt across the power curve in response to throttle demand. It runs at 43 phn/TRM efficiency, consistently, exactly where engineering intended. When maximum output is required, hard acceleration, Highway merging. The system engages both the engine and motor simultaneously in parallel drive mode, delivering combined performance that neither source could achieve independently. Real-world outcomes. Fuel consumption of 4 to 5 liters per 100 kilometers in mixed driving. Electric, only range of 80 to 100 kilometers on a full charge. Total range on a combined full tank and full charge exceeding 1,000 kilometers. And in models like the BYD Chin L approaching 2,000 kilometers. Engine wear reduced because total combustion hours are lower. Cabin noticeably quieter because the majority of driving happens in electric mode. The controlling software evaluates driving conditions continuously and selects the appropriate operating mode without driver input. No manual switching, no compromise forced on the driver. Walk into a BYD facility today, and the visual language is not that of a traditional auto plant. Robotic arms lift engine blocks, mate battery packs, execute structural welds, and route wiring harnesses. Each motion repeated identically thousands of times per day. Automation above 90 PHN/TRM across BYD's leading plants. At specific production lines, 97 PHN/TRM, a single technician monitors multiple robotic stations simultaneously. Speed and error rates that manual assembly cannot come close to matching. Quality control operates at the same precision level. AI-driven vision systems and laser sensors scan components at every production stage. A dimensional deviation of fractions of a millimeter triggers an immediate alert and halts the line. Digital twin technology creates a complete virtual replica of each production line. Engineers simulate configuration changes and stress. Test processes and software before touching a single physical component on the factory floor. Problems are resolved before they materialize in production. The challenges are real and shouldn't be understated. Lithium, nickel, and cobalt prices are governed by global commodity markets and geopolitical dynamics beyond any single company's control. Trade tensions between China and major Western markets introduce policy uncertainty. Local content requirements in Europe add complexity to every international expansion plan. BYD's response takes multiple forms. Upstream mining partnerships, diversified across regions. Battery recycling programs to recover critical materials from end-of-life packs. And the next generation of DMI designed to accommodate sodium-ion battery chemistry, reducing lithium dependency at the architecture level, rather than treating it as a supply chain problem to be managed. Global manufacturing expansion is already underway. Assembly plants are operational in Brazil, Thailand, and Uzbekistan. Factories are under construction in Hungary and Turkey. Core powertrain production currently remains centered in China, where production depth is unmatched. Full localized powertrain manufacturing in international markets is the next phase of the strategy. The next generation DMI pushes further in every dimension. Electric only range beyond 100 kilometers. Total combined range past 2,000 kilometers. A smaller and lighter engine, and over-the-air software updates capable of improving energy management on vehicles already in customer hands. So a car purchased today performs meaningfully better 3 years from now than it did on delivery day. The competitive pressure is landing. Toyota is accelerating hybrid development timelines. Tata is restructuring its electrification roadmap. Tesla is paying close attention to plug-in hybrid demand data, because what the numbers are showing, across Southeast Asia, South America, and growing segments of Europe, is that consumers are choosing PHEVs over full EVs at rates the industry didn't forecast. Range confidence is a real purchasing factor, and in that space, BYD's DMI is currently the most capable, most cost-effectively produced, and most accessible option on the market. Every 30 to 60 seconds, another vehicle, another DMI powertrain. The line doesn't stop. The industry is shifting. BYD isn't asking for permission to lead it. Subscribe and hit the bell. The next breakdown is already in production.